Section 2 of Chapter 1, The Night Sky. If you've ever been somewhere that you thought was a pretty dark location and somebody asked you, well, how many stars were out? A lot of people probably exaggerate. Oh my gosh, there were, 1,000,000 stars out last night. Well, you can't see 1,000,000 stars. You can actually only see a few thousand stars. Let's say, for the sake of the notes, 3,000 stars on a very, very clear night somewhere dark. And that's somewhere really, really dark. Okay. Here in South Florida, in the exact area where I live, we can see about 5 stars. I'm just joking, but it's pretty bad. And we'll talk about why it's so bad in a couple minutes. First, our very first really vocabulary term of the year, the point directly above your head. No matter where you're standing on Earth's surface, the point right above your head is called the zenith. The zenith, kind of cool. That's actually an Arabic origin for that word, and we'll discuss why in Chapter 2, the zenith. But let's talk about first, one other thing here actually that's kind of neat, just a basic knowledge of the night sky. Obviously, the North Star, Polaris, the North Star was hugely important in the days of sailing ships across the Atlantic, in the days of exploration, to point sailors, which way was north. But there's just a very simple trick you can use the North Star to actually, discover your latitude, to measure your latitude. It's very, very easy. You find the North Star and you measure the angle that it is above your northern horizon. And whatever angle you come up with, if it's a 45-degree angle above the horizon, guess what? You're at 45 degrees north latitude. Here in South Florida, the North Star, every night of the year, is 26 degrees where we're at. So 26 degrees above the horizon. It's the only thing that stays the same at every astronomy night that I have, whether it's at the beginning of the year in August, whether it's in the middle of the year, whenever it is, it's always at 26 degrees. Now, this works for the North Star. There are places on the Earth, in South America and Australia where you can't see the North Star, unfortunately. And there is no South Star, by the way. There's no particularly bright star located at what we call the South Celestial Pole. But in the Northern Hemisphere, that's a cool little trick for knowing your latitude. Now, let's get back to my little joke there about not seeing many stars in South Florida. Here's why. Take a look at the bottom left picture. This is a light pollution map of Florida. Okay? Now, in this map, black is the best. All right? That's the darkest skies you can get. And then gray, still good, nice dark skies. And then blue, which is not bad at all. Not bad. And then green, then yellow, orange, red. And the absolute worst would be the white regions. Now, I'm actually broadcasting here from Coral Springs, Parkland, right down here in South Florida. About the worst place imaginable, unfortunately, for astronomy. Yeah, we're right there with all that light pollution of South Florida, Miami, Broward up into West Palm. Here you can actually see Orlando there and the Tampa area. So unfortunately for us here in South Florida, if we want some dark skies, we have to drive out into the Everglades, which can be a little harrowing at times. And this location right here is the best place in South Florida, but there are also some blue areas here in the Keys, and they actually have a star party every year, what's called a star party, where everybody brings their telescopes and stuff. I think it's usually in January or February, and down in the Keys. There's also an area, there's a star party up here, right in this nook right up here that's very dark. Anyhow, we do what we can. Now, what kind of difference does light pollution make from the cities? Well, check it out. At the upper left here, both of these pictures I took with the same camera, the same exposure time. All the settings on the camera were exactly the same. And I took the upper left one here in Coral Springs, and I took this bottom right one in the middle of the Everglades. Yeah, it's the same patch of sky. It's pointed at the same exact way. I mean, you can just barely see 1 point, 2 points, 3 points, 1, 2, 3 there. That's what's called the Northern Cross. Okay? And that's all you can see, just those really few stars. And down here, look how gorgeous that is. So, and that obviously you can see the Milky Way And so it's a huge difference. I was sent this next picture from one of my favorite all-time students, a man named Blake Porter. He's now a doctor, Dr. Blake Porter in New Zealand, I believe. And he sent me this years ago, back when he was in college. He's actually a student that really kind of got me a little bit into astrophotography at the beginning. So appreciate that, Blake, class of 2009. My own Milky Way pictures just got a lot better because I was able to do some traveling this summer. And this is now my best Milky Way picture probably that I've taken. This was in Chile. This is the what you're looking at the left there. That's the at Cerro Tololo Inter-American Observatory. That is the Blanco telescope inside that observatory, the Blanco. And so we were just outside. What was a freezing night? But you can see there some of the pictures I got that night that I'll never forget. Gorgeous, gorgeous night. The darkest skies you can imagine. Anyway, so what do you look for in the skies? Well, of course, ancient people didn't have TVs and computers and their cell phones out, so they would sit around at night and look at the stars, and pretty soon they started making pictures out of the stars, kind of like people make pictures out of the clouds. And there's no reason that different cultures would come up with the same pictures, and for the most part they didn't. They'd have wildly different, interpretations of the same set of stars. Like, for example, Scorpius. What we call Scorpius is the scorpion. It has that curved tail. But if you've ever seen the movie Moana, you know that some cultures then had that as a giant fish hook. And that fish hook would, brought up the Hawaiian Islands in the stories, in the mythology. Because, of course, they didn't just stop with pictures. Then they start turning the pictures into stories called mythology. And there were different mythological stories all around the world and at different times in history. Probably one of the most notable ones, for example, is the Big Dipper. You would think that everybody, and the Big Dipper, by the way, is actually part of a constellation called Ursa Major, the Great Bear. But the most noticeable part we call the Big Dipper. And even that one had different interpretations. In parts of Europe, it was called the Plough, for example. One thing you should know is that most of the time, the vast majority of the time, stars in a constellation are not actually close together. They're nowhere near each other. I'm going to give you an example here, and I hate to keep using that. When something in the sky is not an official constellation, but it still makes a picture, it's called an asterism. I like to call asterisms picture in picture, like you have on a TV screen, a picture in picture. That's what an asterism is. The Big Dipper is part of Ursa Major. So the Big Dipper itself, you could probably win some money on a bet. The Big Dipper is not a constellation. It's not listed as a constellation. It's an asterism. Orion's belt is part of the constellation Orion, but the famous part, the belt part, it's not a constellation. It's an asterism. Those three stars in the belt, they're nowhere close to each other, as you're going to see. It just looks that way because you can't tell. It's very hard to tell depth standing in your backyard and looking at the blackness and the vastness of space. You can't tell how far away things are. It's very, very misleading. If you see a bright star, is that a bright star? Or is it just close to us? You don't know. If you see a very dim star, is that a star that's actually not putting out much light? Or is that a very, very distant star? You don't know that with just your eyes. So anyway, here's the Big Dipper, as I mentioned. There you see the Milky Way on the left. These are the Grand Teton Mountains. Oh, I'll show you something kind of cool here you can do. Here's the Big Dipper over here. And here's one thing that's kind of fun. If you follow the arc of the handle here and just keep curving around, you get to one of the brightest stars in the sky. I think it's maybe the fourth brightest. It's called Arcturus. And the famous saying is, you arc to Arcturus. That's how you find it. Arc to Arcturus. And you would find that in the springtime. Here's a great example. Well, there's Mount Rushmore. Very neat. There you can arc to Arcturus is down there in the corner. See the Big Dipper right there. And then something important you can do with the Big Dipper. The Big Dipper is located in the northern part of the sky. And if you think about the end of the cup, like where you would pour out some milk or something, the very end of the cup right here, these two stars point roughly in the direction of a very important star right there. The North Star. The North Star. There it is. That's an easy way to find the North Star. If you can find the Big Dipper, you can find Polaris. And by the way, Polaris, 1, 2, 3, 1, 2, 3, 4. If you follow the cursor there, that is the Little Dipper. Another asterism, part of Ursa Minor. Anyway, it's kind of neat. I'm going to skip some of these. There you see again that Polaris is the end of the handle of the Little Dipper. Not quite truly rotational north, but pretty darn close to what we call the North Celestial Pole. And there's good old Orion, probably my favorite constellation. There's the famous belt. 1, 2, 3, believe it or not, those stars, they sure look like they're close together, but they are not. Now, when you see Orion, look at those stars. What do you kind of envision in your mind if you're an ancient person? Well, of course, you envision this, right? Of course, right? The picture on the right. Yeah, I don't always know how they came up with some of these, but anyway, so you have Orion was the hunter in the Greek mythology, and the famous belt. We're going to talk a lot about Orion later on, but the point here is, look at this. If you look at those 3 belt stars, we're on a scale down here of 1,000 light years, by the way, so none of them are like right in our neighborhood or anything, but those 3 belt stars, that middle star, for example, is much for hundreds of light years farther away than the other 2. And what does that tell you about that middle star? That it's brighter. It's naturally must be much brighter because it appears to be the same brightness as the other 2, even though it's much farther away. We'll get into that more later in the year. Every single star in the sky is part of one and only one constellation. That's it. One and only one. There are 88 official constellations, the same number as the number of keys on a piano. 88. So I look at it this way. It's kind of like cities and states. A city can't say that it is both in Georgia and in Florida. It's one or the other. You can't be both. And every star is part of one and only one constellation. And really, the idea, obviously, of constellations has been around for thousands of years. There's nothing better. It's just the best way to divide up the sky into rough patches and know where things are at. Some individual stars have always been important in history. I mentioned Polaris already. Sirius is nicknamed the dog star. It's the brightest star in the night sky. It is the brightest star. It was particularly important to, for example, just to give some history here, the ancient Egyptians, because it turns out the first time that they would see Sirius, they knew it was close to the time when the Nile would flood and they'd have water for irrigation. So they actually based their calendar on the star Sirius. It's also where we get the phrase "dog days of summer," because that's around August is when they could first see Sirius in the sky. Okay, and one last thing here: the names of stars. The names of stars. How do stars get their names? Very interesting stuff. Every star has a scientific name that consists of 2 things. The first thing is their home constellation, where they're at. And the second thing is how bright they are within that constellation. The brightest star within a constellation gets to be called Alpha. So the brightest star in Orion is Alpha Orionis. The second brightest is Beta Orionis, and so forth. Alpha Ursa Majoris is the brightest star in Ursa Major. Alpha Ursa Minoris is the brightest star in Ursa Minor, except a lot of the brightest stars also have what you call common names. So Polaris is the common name. The scientific name for Polaris is Alpha Ursa Minoris, even though even scientists aren't going to really call it that. Now, if you're the brightest star in your constellation, it doesn't mean you're necessarily bright. So here, the brightest star, that's Pisces, and that star at the bottom there is the Alpha star, but it's not particularly bright. It's kind of like saying you're we're the biggest city in, Arkansas, you're Little Rock. Well, Little Rock's not some major city though. Okay. But it's still the biggest city in Arkansas. So it gets to be sort of the Alpha city, if you will. Okay. I'm going to save the celestial sphere for next time. Thanks for listening.